Okay, hi everybody. We're working through the diploma prep here. We're looking at the chapter on transformations. This is specifically the lesson on stretches. In this case right here, what we're going to do is we're going to do question 1b here. It says, given the function f of x equals the absolute value of x minus 1 minus 4, write the equation of each transform function if. Okay, well, let's do these, actually maybe let's do both of these together here. I was going to do B. Let's do them both here. First of all, if it's stretched about the x-axis by a factor of 1/3, a stretch about the x-axis is a vertical stretch. The x-axis is in the middle and everything's moving up or down. So the line in the middle, the x-axis, is in the middle of it. So if that's true, okay, what we're going to do here is make this y equals, well, to get a stretch by a factor of 1/3, okay, what I do is I just write it out in front of the function as 1/3. Okay, if I was to write it on the y, I would put it as 3y, okay, knowing that when I bring it over, I would divide by 3, and that will give me the actual stretch factor. Now, in this case, though, the original function is, and I want to make sure I get everything in brackets here, x minus 1 minus 4. That stretch here should distribute to both of those terms to get you 1/3 x minus 1 in absolute values minus 4/3. Okay, so a vertical stretch will affect all the terms in that expansion here. Now I could take that 1/3 and plug it into the absolute value, but there's really no need to do that right now. Over here is the question where we're going to stretch it by a factor of 2 about the y-axis. Well, again, if it's about the y-axis, that's a vertical axis. The stretching is going either away from the y-axis or towards the y-axis, but the y-axis is the middle one here. So this is a horizontal stretch, and if I want this to be by a factor of 2, what I need to do is plug a 1/2 in front of the x. Because I just think about it, what that means is, if I was to try to isolate the x here, the very last thing that I would do would be to multiply by a factor of 2, just like it says here. And that's how I know that I've done that right. If the very last thing that I would do corresponds to the stretch that I want. And so now what I would do is I would plug in the half into the x, the 1/2 x into the x in the formula here. Now, the problem is I need to separate that 1/2 x from the translation here. We're going to see in a little while here how seriously this impacts the translation here. When you are stretching something that had been translated beforehand, basically what's going on here is we're doing this in the wrong order. Okay, we're doing the stretch after the translation, and it gives us a little bit of difficulty here because a horizontal stretch, can actually move something closer to the x-axis or closer to the y-axis or further away. It looks like a translation even though it's just a result of the stretch. So to clearly see what part of this motion is responsible, is due to the stretch and due to the translation, I have to separate that 1/2 out. I have to divide that out of those two terms to get x minus, now this is going to cause people some stress here, but x minus 2, and then with a minus 4 out here. Okay, that's minus 2 because when I factor the 1/2 out, factoring a half out of 1 is like multiplying by 2. You have to, when I divide out the 1/2, I have to multiply by the reciprocal, and so that's what that's going to look like.